Yes, students, by the continuation of the topic, now we are going to discuss about NPN-CE mode characteristics study. Yes. So this is the circuit diagram. As since we want to measure input current, input voltage, output current and output voltage, so we have to connect the suitable ammeter and voltmeters. We know that ammeter is connected in series and voltmeter is parallel in the external circuits. That and all we know that. Just to see that since we are talking about NPN transistor, so NPN, so base layer is positive, that means a forward bias, so that is connected to positive, and we know that obviously the current is coming from the positive terminal of the battery. So IB, since as we said earlier that the value of IB is less, that is in microampere, and the value of IC in milliampere. In what manner the polarity of the voltmeters are marked and that voltmeter and ammeters are marked means, since this terminal is connected to positive of the battery, therefore plus minus is there. Similarly, this is the positive potential, therefore plus minus is there. So similarly here also, as this terminal is connected to positive of the reverse bias battery, therefore this is positive, and this will be what, children? Negative. Similarly here also this will be the positive potential and this will be negative potential, therefore plus minus symbols are there. It is my very easy, what is that, hint or suggestion that whenever such type of circuits are given, sir, how to write the voltage formula or current formula or resistance formula means, it's a very simple idea. So the hint what I am going to given to you is, yes, now you please consider the children. By the energy conservation, you know that generally energy conservation, know that applied voltage is equal to, just to keep in mind that applied voltage is equal to sum of the voltage in the remaining part of the circuit. So as for example, if you consider this is input part and this has to be output part. So input part, this has to be what, children? Output part. So what hint I am telling children? The applied voltage is equal to sum of the voltage, sum of the what, children? Voltage in the remaining part of the circuit, For example, sir, how to understand these hints or means? For example, at the output part, at the what, children? Output part, so this is our applied voltage. What I said? Applied voltage, that is VCC, applied voltage is equal to sum of the voltage in the remaining part of the output part. So what is the voltage? So since IC is going in this manner, there will be a potential drop across this collector resistance. RC means what, children? Collector resistance. Therefore, that is Ohm's law, IC RC, plus there will be a potential difference between the collector and emitter region. That potential difference between the junction is called what, children? VCE. Yes. So these are the voltage in the remaining part of the output circuit. That's why I said applied voltage is equal to sum of the voltage in the remaining part of the circuit. Similarly for input part, this is the applied voltage and that is equal to potential drop across the base layer and potential difference between the base and the emitter layer. Okay. So similarly at the input part, I can say that VBB, that is equal to what, children? IBRB plus what, children? Yes, VBE, the potential difference between the emitter base junction. Yes. So this is the very easy point you just keep in mind to deal any kind of circuits and the Ohm's law, obviously Ohm's law, and that and all you are already studied in current electricity. Okay. So the first characteristics what I am going to discuss is input characteristics. What, children? Input characteristics. Okay. Yes, input characteristics. What is this input characteristics or means? Variation of, yes, I can say that variation of input current, that is IB. So variation of IB, input current, due to what, children? Due to the variation of input voltage, that is VB. This is the biasing voltage and this will act as input voltage. You know that during the forward bias of the junction diode, we just remember that up to a certain value of forward bias voltage, the current in the diode will be 0. Once the applied voltage is greater than the knee voltage, then what will happen, children? The current will be increases in this manner. Yes, I hope that you can remember from the diode properties. So I don't want to waste my time here, since you know, I hope that you know that. So the variation of IB due to the variation of VB, at constant VCE, at constant what children? Yes, VCE, where VCE is considered to be output voltage. So now I am going to draw the data is plotted in a graph. So this is what children? Voltage, that is VBE in volt, yes, and this is IB in microampere. In what children? Yes, microampere. Yes. So this graph is very similar to input forward bias characteristics of the junction diode. So up to like this, the graph will be looks like this. Since we are doing this one at the constant output voltage, therefore VCE. If you are writing anything like this, that value is maintained as to be a constant. Okay, children. Yes. So VCE has to be a constant here. Now we just take the slope, and this is what children? Delta IB, and this is what children? Delta VB. We know that the ratio of input voltage and the current is called input resistance or impedance. Therefore I can write that here as what children? The input is impedance. So input resistance, or in some books they may given that has to be impedance. That has to be what children? Impedance. Therefore I can write that R in. So that is R in, that is equal to what children? Yes, we know that Ohm's law. So delta VBE divided by delta IB at constant what children? VCE. So any constant value is there, it can be as written here. Okay, children. Yes, this is the information about input characteristics. The variation of the input current due to the variation in the input voltage for the constant output voltage VCE value. Okay, children. Yes. So this is the information about input characteristics. The second one what we are going to discuss is the second one is output characteristics. What children? Output characteristics. Output characteristics. So this is a little bit important for the conceptual point of view. So what is that? The same manner I can say that. Yes, here also I can say that. Yes, what children? Variation of output current, that is IC, due to the corresponding variation in the output voltage VC. Output voltage what children? VCE, by keeping for the constant for the what children? Constant input current. For the constant what children? Input current, that is IB value for the constant what children? Input current. Yes. So here I am going to draw the two graph. So the first one what I am going to draw is the normal, what is that children? Output characteristics graph. So now you please see that this is VCE in volt, and this will be IC in milliampere. IC in what children? Milliampere. So IC in milliampere, MA, milliampere. So for different values of IB you are drawing the graph. Yes. So when IB is equal to 0, if you are maintaining IB has to be 0 microampere, then there will be a small amount of, very small amount of what children? As a collector current, that is called leakage current. That is called this current. When IB input current IB has to be 0, there will be a small, very small non-zero as a output current IC, that is called what children? Leakage current. Okay. So now this region of the transistor is called cut-off region. Now this region of the transistor, the state of the transistor is called what children? Cut-off region. Yes. Now I am gradually increasing the value of what children? As IB value. So when IB increases, the corresponding, the maximum value reached by the what children? Collector current also increases, because output current obviously depends on input, because the majority carriers are obtained from the what is that? Input part only. So therefore you just see that. So I can say this is IB has to be, for example, 20 microampere, and this has to be what children? 40 microampere. This has to be what children? IB has to be 60 microampere, and so on. Yes. You just see that this part of the circuit, where it will be gradually increases, gradually what children? Increases, and this portion of the is a graph is called what, children? Or state of the transistor in the circuit is called what, children? Saturation region. What, children? Is a saturation region. So this part of the or this part of the graph or that particular condition state for that particular voltage or current, the state of the circuit is generally called what, children? As a saturation condition. What, children? Saturation region. What, children? Saturation condition or saturation region. Saturation what, children? Region. Yes. Now please see, this is cutoff region when IB has to be 0, that we already said that. But there will be a small what, children? A linear variation, very small, what is that? Gradual variation will be there. So this part of the S graph, this region of the graph is represented as to be what, children? Active region. This is what, children? As active as region. Active region, where there will be a gradual variation of input voltage and output voltage and output current, children. That region is called active region. For working of a transistor, since the transistor is going to be used as to be a two main purpose, one has to be electronic circuit and another one is what, children? Is amplifier. Yes. So for this I can say that this will be delta IC and this is what, children? Delta VC. This is what, children? Delta VC. So it will be very small to visible, since I will say that delta VCE and this is delta IC. Change in current value, change in voltage value. Therefore, I can say that the output impedance or resistance. Output impedance or what, children? Resistance. We know that what is the meaning of impedance and all we are already discussed in AC chapter. Okay. So therefore, I can say that R out, that is equal to what, children? Output voltage divided by is corresponding current is at constant what, children? IB. At constant what, children? IB. Okay. Yes. Yes. So in the output characteristics or that is part of the circuit, the transistor may have the three regions, depends on the applied voltage or because the input current depends on input voltage. So therefore you just see that there are three regions when IB has to be 0, input voltage or input current has to be 0, that state of the transistor is called cutoff region. When IC becomes very large or the maximum value, very large or maximum value, so it will reach some maximum value, some what, children? Maximum value, and this portion of the graph is called what, children? Saturation region, where there will be a maximum collector current or output current. And intermediate state between the Imax and that maximum output current and the minimum output current, because I said that even though IB has to be 0, this part having some very small amount of non-zero collector current. So the state of the transistor where the output current is lying between minimum and maximum value, that is called what, children? Active region. Yes, this is the active region for this curve, and similarly this part will be active region of this curve and this curve, like that. Okay. Yes. Now please see that, children, the another parameter what I am going to discuss is B. Yes. So I drawn here a graph between what, children? Output voltage and the what, children? Is output current. Now I am going to relate the input voltage and the output voltage to show that how the transistor can be exist in three different states. Okay. Now please see that, children, as I said as here, just see that this is the what as voltage equation for the output part of the circuit. Output part of the what, children? Circuit. Therefore, if there is a change in small change in input part, if there is a small change in input part, definitely that will make the corresponding change in the output part of the circuit. So a change means what is that, children? Differentiate, or we can take the delta. So I am just differentiating this. So what I can get, children? So this VCC, the applied biasing voltages are constant. VBB as constant. Similarly VCC also what, children? Constant. So that is if let us assume that if there is a small change in input voltage, if there is a small change in what, children? Input voltage, that is V in, that is what, children? Is V in, and there will that change in input part, whatever the change happen in the input part, will reflect in the output part. So there should be a corresponding change in output part also. There will be a corresponding change in what, children? Output part. Corresponding change in what, children? Output voltage or part. So please see, the change means just a differentiate. Constant differentiation is what, children? Yes, obviously that will be 0. But these values are variable. So therefore I can write that the corresponding change in the output voltage equation, change in delta, yes, delta will be 0 because constant differentiation will be 0. Therefore 0 equal to what, children? Yes, IC RC plus what, children? VCE. IC what, children? RC plus VCE. Yes, since it is change, we can write that has to be delta IC, and similarly I can write that has to be delta VCE also. Delta what, children? VCE. So delta VCE. Now this delta VCE is considered to be V out. This delta VCE considers to be what, children? V out. Therefore I can say that yes, V out equal to what, children? Minus delta IC into what, children? RC. Minus delta IC into what, children? RC. Yes, yes. Now please see that I am going to draw the graph between yes, what, children? Yes, output voltage and the input voltage. Output voltage and what, children? Input voltage. So this is the input voltage V in, and this will be output voltage V out. So input is what, sir? Change in delta VBE is called what, children? Input voltage. So that is simply taken as to be V in. That is taken as to be simply taken as to be V in. V in is nothing but what, children? You just differentiate this. This will be 0. Yes, we can say that IBRB, delta IBRB, corresponding change in that delta VBE. This delta VBE is considered to be input voltage. Yes, therefore V in, and there will be yes, V out. Okay. So when V in is 0, what will happen, children? Yes, when, so I can say that if the first case is, suppose if V in has to be 0, when V in has to be 0, therefore what will happen, children? Yes, V out will be 0. V out will be what, children? 0. Therefore we just see that V out 0 means there is no, yes, what is that, children? Yes, collector current, or the collector current will be very less. Collector current will be what, children? Very less or negligible. So if you neglect the collector current, then what we can get, children? Yes, VCC has to be VCE. That means this change in VCE considers to be yes, our output voltage. So therefore when V in is 0, or we can say that IB has to be 0, yes, the corresponding IC also what, children? 0. The corresponding IC also 0. Therefore this term is approximately equal to 0. Therefore you just see that VCC equal to VCE. That means the output value will be constant as to that of the applied maximum reverse bias voltage up to the certain value, until the diode or the forward bias current becomes a non-zero value. The output current will be, voltage will be what, children? Keep on constant up to a certain region. Up to what, children? Certain region. Now if the applied voltage, input voltage is greater than the new voltage, what will happen, children? That means the input as voltage what we are going to apply is increases beyond the or more greater than the new voltage, then there will be a input current. That means if V in is increases gradually, then IB also what, children? Increases. IB also what, children? Increases. Therefore IC also will be increases. Therefore IC also will be increases. When IC increases, you just see that relation. Yes, just see that when IB increases, corresponding IC also increases. This yes, IC increases mean the value of what is that, children? The output voltage VC also gets yes, increases. Yes, now please see that when input voltage increases, the corresponding yes, value of output voltage was we said. You please be careful with this. Once again I am explaining that when input voltage increases, IB also increases. When IB increases, what will happen, children? IC value also get increases, but IC value is in negative value, negative sign. Therefore it indicates that the value of output will be decreases from its positive value, decreases from its what, children? Positive value up to a certain region, up to a certain region. Yes, when V in will be yes, maximum. So if V in becomes maximum value, so therefore corresponding IB also increases maximum, and here, so here I can say that IC increases. If input voltage is increases to the maximum value, and corresponding IB also can increases, and corresponding IC also, what children, increases much. We know that negative number, if minus 5 minus 1, which is lesser value, means minus 5 is lesser when compared to minus 1. Similarly, when IC increases much with the negative sign, we can say that the value of output voltage is decreases. Therefore, up to that region, is the value of that voltage range is what children, greater than 1 volt. For example, greater than 1 volt, what will happen children? Yes, we know that what is a barrier potential, that concept and all. Okay, so when input voltage is greater than, approximately for example greater than 1 volt, then there will be a maximum current, input current, and there will be a corresponding maximum current which reduce the corresponding voltage, that is a delta VC value. Therefore, when V in increases, the value of output voltage gets what children, decreases. Yes, and this part, when output has to be maximum, when there is no input current, as we said here, that is called what children, cutoff region. So that is what children, this is a cutoff region. Yes, but for V in as increases greater than the new voltage, there is a, what is that, input current. So when input increases gradually, there is a corresponding increase in the value of IC, that means output current, and there will be a decrease in its value. Previously, when IB is 0, as we said, when IB is 0, IC also approximately 0, then VCC will be very high positive value up to this region, that is called what children, cutoff region. So between the, for example, we know that germanium, we can say that will be what is that, silicon, that will be approximately 0.6, I think, that barrier potential. So therefore the applied voltage is greater than the 0.6 voltage, then what will happen children, the input current will be gets increases, there is a corresponding increase in what children, in output current. When output increases with the negative sign, we can say that value of output will be decreases, and this region where there is a smooth change in that is called what children, active region. For the transistor as an amplifier, what children, transistor as a amplifier, this region is used as amplifier circuit. That means amplifier. So this part we have to maintain our transistor within this condition in order to use the transistor as a amplifier. But when the Vin is maximum, that is more than the 1 volt, for example, then as we said here, when IB reaches the maximum, there is a corresponding maximum output current, then it will decrease the output voltage. So this region is called what children? Maximum current means saturation. Maximum current means what children? Saturation, what we said here. So this region is called what children? Saturation region. What children? Saturation region. This region is called what children? Saturation region. Yes. Okay. As I said, a transistor can be used as the what children? As a switch as well as the amplifier. Amplifier will be discussed as a separate topic. But if you are maintaining your transistor under this condition, that means IB has to be 0, there will be a very negligible amount of IC, or we can say that there will be a maximum output voltage. Maximum output voltage, that condition is called what children? Cutoff region. So that is called off state. That means there is no output current. Even though it is very small, we consider approximated as to be 0. That's why I am telling that output current has to be 0. So current is 0 means the switch means what children? When the switch is off condition, no current flow in that. So I can say that this is off state of the transistor as a switch. Now if the transistor maintained at the saturation region, you just see that cut off saturation, the last letter is what children? On. So the saturation, just to keep that idea in mind, to keep that condition. Yes, saturation, the word saturation is what children? Saturation, the last letter is what children? On. So whenever a transistor is maintained at the saturation condition, that condition is said to be on state of the switch. So when the switch is on, what will happen? There will be a maximum output current. That's why we said there is a maximum output current. So this is called what, children? As a cut off. This condition is called what? This condition is called what, children? Cut off. And this condition is called what, children? Active. And this is what, children? As a saturation. This is what, children? Saturation. So if we want to use the transistor as a electronic switch, by mechanical switch we know that switchboard and all, we saw that very big in size, but when you make these smaller electronic circuits, we cannot use such type of mechanical switch. Instead of that, a small transistor can be used as a switch. So by maintaining the transistor under this condition, the transistor will act as a off state. That means there is no flow of current in the circuit. When the transistor is maintained under this condition, then there will be a gradual variation in the current and voltage value, that is called active region. This active region is used for transistor as a amplifier circuit, used for designing the amplifier circuit. And for this condition, where there will be a maximum current, that is called what, children? Saturation. That means when the switch is on condition, the circuit will allow the circuit to conduct the maximum current. That's why he said saturation. The word lost itself. On condition means saturation, on state, cut off. So like this, you just keep in mind, children, to as easy remembrance of the concept. Yes, this is the information about output characteristics and how the transistor can be used as a switch. Yes, this is the explanation. Yes, here alone, you please listen carefully 1 or 2 times and make the notes. Yes, kindly note down the theory part, students. The third transistor characteristics is transfer characteristics. Transfer characteristics is characteristics. Okay, yes. In this, what we are going to do means we are going to study the relation between output current and the input current. So this is input current in C mode microampere, and this is output current, what, children? In milliampere. Yes. As I said, even though IB is 0, there will be a non-zero, what, children? Yes, IC value. Non-zero, what, children? IC value. So the graph will not exactly start from the origin of the graph, and this will be like this. There will be some small current, that is called a leakage current. This is maintained at constant VC. This is maintained at constant, what, children? VC value. So now please see that this is a delta IC and this will be delta IB. So therefore the current gain, we know that just now we said, so therefore the current gain, so that is what, children? Beta is equal to what, children? Is output current is divided by input current. Output current divided by what, children? Input current, that is delta IC divided by delta IB at constant, what, children? VCE. Yes. If you are calculating beta value by considering the change in change in currents, that is delta IC by delta IB, like that, the corresponding current gain is considered to be AC gain. Corresponding what is that current gain is called what, children? AC gain. Suppose if you are writing beta has to be a instant value IB by IC at any particular point. At any particular point, what is IB? What is IC? In that manner, if you are calculating, that is called what, children? DC gain. That is called what, children? Yes, DC gain. Yes, DC current gain. Yes, the value of beta for a normal transistor we already discussed. That will be lies between 50 to 300, and some transistor may have the what, children? 1000 has to be beta value. The last one in the characteristics study is Transistor-Ce conductance. So what, children? Is a transconductance. Transconductance. So what, children? Conductance. So what is the transconductance means? It is generally represented by a small gm as a transconductance. So that is nothing but what, children? Is current gain. That is what, children? Current gain by input voltage. Current gain by what, children? Input voltage. Yes, we know that the same can be written as this can be written as current gain divided by what, children? Input resistance. I am sorry. So the transconductance is what, children? Current gain by input resistance. Current gain by what, children? Input resistance. Or the same can be written as GM. As GM, that is equal to what, children? So the beta. Yes, we can write that. We just see that this can be written as V in, this has to be I out. There are two definitions for transconductance. One is the ratio of current gain and the input resistance, and another definition is output current by input resistance. Output current by what, children? Input resistance. So from this, input voltage is nothing but input current into input resistance. What is the numerator, children? I out is there. We know that the output current by input current is called beta. Output current by input called is what, children? Beta. So this is nothing but what, children? In CE mode, that is beta. So Rin. So there are two definitions for transconductance. One is current gain by input resistance, or the actual definition is output current by input voltage. That is called what, children? Transconductance. The another one is the reciprocal of this. So that is called trans resistance. Trans what, children? Trans resistance. So trans resistance is nothing but the reciprocal of this GM. The reciprocal of what, children? This GM. And unit and all, you know that. For example, you just see that the beta has no as a unit since it is ratio of the same quantity. So 1 by as ohm. That is nothing but ohm inverse or is what, children? Simon. Ohm inverse or Simon. That and all you studied in current electricity. So the reciprocal of this is called what, children? Trans resistance. So this is the very detailed explanation about the transistor characteristics in NPN C mode configuration. NPN what, children? C mode configuration. Yes. So this is the core part area for the problem solving purpose. Yes. Please kindly note down, children.